Good day, folks. So here is the secret to supercapacitors. If you haven't watched it, I recommend watching my previous video before this to understand the full scope. I even have a little circuit diagram of the connection here. But back to what Tom Bearden was saying, when you have certain materials like dielectrics, like barium based, many supercapacitors do. It might not be exactly barium titanate, but things like that have similar properties. And as Tom Bearden was saying, if you pulse them just right or expose them to fields, interesting things happen. Now in this configuration, when we're feeding one plate with one wire live, and the other plate here goes to the microwave transformer high voltage side, and the other secondary side to ground here, we get the displacement current. But what's very interesting is this creates a memory effect inside the supercapacitors because of the high dielectrics. So in other words, the exposing of the very high voltage, high frequency field causes essentially the supercap to lock in also the DC voltage in the memory, because it basically kind of makes it like an electric triggered version of an electret, if that makes any sense. It does a little magnetized, well, not magnetized, but electric dipoles, polarized. And then because of the energy field, that creates a memory effect. And essentially what I'm getting at is if you charge them because of this feedback mechanism that I showed you in the last video, let's say 1 or 1.9 volts, if you pulse them from the memory effect, they'll come right back to the last voltage without having, these are supercapacitors like 500F, folks. So even with a good power supply, it takes a couple minutes, even at 2 volts or so, to bring them back up. So the fact that they're bouncing right back up right away means essentially you can continuously pulse them like at 60 Hertz with very minimal strain on the input as long as they're exposed to that field. So we're using them as a 2-for-1. So here I have it now measuring at 2.04, continuously rising. So these two wires here are connected to here. So I can short it completely. What you would expect is it to go right away to 0 after the initial discharge, right? And I've got the motor in parallel with this output. So the motor should stop right away and the voltage should go to 0, the path of least resistance, right? So you'll notice something here. I'm going to short it out. So I'm shorting it out right now, and see what happens. The voltage doesn't go down completely. It actually goes down a bit and bounces back up. And the motor doesn't stop. It should. I'm still shorting it out. I release it. It goes back up to just about what it was before from the memory effect, and the motor's running back at the same speed. So you get what I'm getting at? I didn't have to wait the 2-3 minutes for the 500F to come back. The memory effect under the exposed field caused this rebound effect because of the special dielectric materials they have here. It's a novel interaction, and Don Smith actually told us. He said use supercapacitors. And when you start doing the math, folks, it gets a little crazy, because at like 500F, even if it's just 2 volts discharges into a properly tuned transformer, let's say, you're getting like over 20 kilowatts of output if you step it up to like 110 volts. That's like including the transformer inefficiencies. So it explains how Don Smith was able to basically get any power he wanted by hooking up the right transformer and pulsing his, he even said it, he had one of the early versions of supercaps. He found a few farads, and he claimed that was enough to generate, without explanation, a few kilowatts of power. This would explain it. And what's interesting is I can turn off the load here, and it doesn't charge that much quicker. They gave it a little nudge there, but see, it's off, and I can turn it back on, and then it keeps charging up. It's like it doesn't even sense it. It's this memory effect. So it just makes sense to pulse, right? So very little to keep them going in this condition. So I tried with regular capacitors, I wasn't getting the same effect, but when I moved over to supercapacitors, all I could say is, wow. So just thought I'd share that with you folks. Supercapacitors. And again, if you're not sure, please watch the previous video with the circuit hookup of this. Again, thank you all for watching.